Can we start the event?
Yeah, I think.
Okay, thank you. Yeah. Good morning, good afternoon, good evening. I have to greet in such way because we are all from the entire world, someone from US, someone from Japan, someone from mid of Asia. So that I used to greet like this. Very first, welcome you all for the Pre-RoboCup Rescue Robot League. It's the event which we are organizing like a pre-event for our coming Rescue Robot League, for our coming RoboCup 2022 at Bangkok. So very first, I would like to introduce myself. My name is Branish. I'm working as a faculty member at Mahidol University, and I'm also one of the local organizing chair for Rescue Robot League. So the very first, I would like to, before going to invite the guest and invite the speakers, I would like to say some words in a short way of what is Rescue Robot League, and then I would like to hand over the dice to our honorary guest. The very first, the Rescue Robot League is actually it's an international competition for urban search and rescue robots, in which the robots compete to find the victims in simulated disaster environment. The Rescue Robot League is run alongside with the Rescue Robot Simulation also as a part of RoboCup competition. So one more word I would like to add with this is, it is inspired by the Kobe earthquake, the first RoboCup rescue competition held in RoboCup 2021. The aim of the competition is to encourage the transfer of academic research into the disaster rescue domain and to encourage research in social, significant, real world domain. That is like the word which has been given as a definition for this, or like we can say it is a mission or vision towards RoboCup Rescue Robot League. Very first, I would like to introduce the guest of today is the local organizing committee chair, Professor Irapat from Thailand, and I would like to welcome him. Next, I would like to welcome Professor Raymond, Executive Committee of RoboCup Federation. I would like to welcome Professor Kimura, is also the Executive Committee of RoboCup Federation. Very first, Professor Raymond will be like delivering a talk about pre-RoboCup introduction rules for RoboCup Rescue Robot League. Before I'm asking to hand over, before I'm asking to present, I would like to say a small word about Professor Raymond. His primary research interest is mostly on trusted autonomous system, particularly in the area of expandables and artificial intelligence, and also the development of standard test method for robot performance and the cyber security of artificial intelligence and cyber physical systems. Actually, he is currently a research professor at Georgetown University Institute of Soft Matter Synthesis and Meteorology, and he is working with NIST, US National Institute of Standard and Technology, on developing standard test methods for response robots. So I would like to invite Professor Raymond to give his valuable talk. Welcoming you, sir.
Yes, well, thank you, Branish, so much for the kind introduction. Let me just get the sharing up.
Yeah.
Let's see. I think that's the correct one. Okay, so you can see my slides?
Yeah, great.
Perfect. Okay, well, thank you so much again. I'm Raymond Shea, and in this presentation, we will talk briefly about the introduction of the league, some of the rules and regulations, and then Professor Kimura will talk a bit about some of the history and the connection of RoboCup Rescue to everything else in the technical aspects presentation, and then we'll have some opportunity for question and answer. First, I just want to acknowledge the rest of the committee. In particular, Adam Jagoff and Satoshi Tadokoro, Professor Tadokoro, who together were the founders of the competition. But of course, this competition relies on the contributions of many people in various committees, both present and past. We're also very grateful for the local organizing committee in Thailand this year for their work, especially in very, very challenging conditions. So what is the League about? At the end of the day, we're talking about making sure that the emergency responders have the tools that they need in order to perform their tasks, their extremely hazardous tasks in very complex environments from safe standoff distances. What we don't want to have happen is the person who has to go downrange in a bomb suit to a known explosive to deal with it. We want this to be done with robots. And a very important part of being able to do this with robots is to provide a way of communicating the requirements and capabilities between researchers, manufacturers, and emergency responders to refine, measure, and highlight breakthrough capabilities. So the RoboCupRescue Robot League falls within a broader project called the Standard Test Methods for Response Robots project, based here at NIST to generate the measurement science that allows these capabilities to be measured and communicated. So standard test methods facilitate this communication, and within the competition, responders and manufacturers learn about the emerging technologies. The researchers who are participating in this competition, the academics, learn about the operational needs and the gaps in the current capabilities. And local responders at every location where we run this competition get to keep these tests that make up the arena that we build every year to develop their own test facilities. So, for instance, the last year that this ran in Sydney, the arena that was built, half of it went to the New South Wales Police Rescue Squad, and they're using it to not only train their robot operators and to test their robots, but also to test people who do have to get into bomb suits. And half of it went to an organization called EPE in Queensland, where they're building a whole test facility for both for academic, commercial, and military use to test the robots that they need to use. So the League itself helps to develop and validate standard test methods used worldwide by emergency responders as part of the Standard Test Methods for Response Robots project, and also as part of ASTM Subcommittee E54 on Homeland Security Applications Response Robots. We test basic capabilities of mobility, dexterity, exploration, mapping, and through that, things also like sensing and human factors. We operate at a variety of scales. Those of you who are familiar with the competition will be familiar with the 120 centimeter scale, which represents public buildings and outdoor environments, car parks, things like that. But we also have 60 centimeters and 30 centimeter scales that I'll show you in a moment. Our focus has been on ground robots, although we are now expanding to legged robots as well, and aerial robots in recent years. And the tests are performed individually in standardized methods, as well as sequenced in more realistic situations. So the League itself is broken up into preliminary rounds consisting of the standard test methods performed individually. The teams select which test to run with scores normalized to the best performers in each test. And the best performing teams qualify for the finals where the tests are harder and sequenced. The championship award is given to the best performing team in the finals. However, we also have a large number of best in class awards for performance in specific groups or specific suites of tests during the preliminary rounds. This means that we are not only encouraging the team that does the best and gets the award, but also teams that have developed specific capabilities that we are interested in, even if they're not able to put together a team that manages to win the overall competition. Every year, just in the major side, we'll talk about the juniors later, but in the major side, more than 300 trials are conducted in every competition. During the preliminary rounds, the arena runs concurrently. In the year that is shown on this board, we had 6 teams running at the same time within this arena. This massive concurrency allows us to have statistically significant trials, even with a large number of teams. The teams proctor and score each other to practice conducting tests from themselves. They can choose what they focus on. Now, the important thing here is that the robots can look quite similar. Success is often imitated, and there is often some kind of convergence to some particular form factor. Here, then, it is very important to use standard test methods, these statistically significant measures of performance data, in order to identify where the differences are and what capabilities, what differences should be replicated by everyone else. This is a very open competition where everyone learns from each other. And the use of the standard test methods means that your performance and my performance can be specifically compared and related to the differences in our designs and implementations. This is how the state of the art pushes forward. And of course, between the different suites of tests, we're able to compare robots that are designed for different purposes. And we have these radar charts that people may be familiar with, which show good performance in different parts of the problem. While so this highlights specific focuses in different areas, while the overall championship then normalizes this to the best performing robot overall. So talking about the scales of the environments in which we operate. This is the one that we're all familiar with. This is the 120 centimeter scale, open areas, car parks, public buildings, where you have a fair bit of free space to operate in, even if the free space has now been contaminated with rubble or the like. The 60 centimeter scale now represents things like dwellings, public transportation, spaces between parked cars and the like. Note that this isn't a scaling down of the environment. This is still a full-size environment, but it's for smaller robots or large robots designed to go into small environments that need to now change their shape to deal with it. And then we have the 30 centimeter scale. Some of you may know this as the Mini Arena or the Rapidly Manufactured Robot Challenge, the RMRC, which we'll talk about tomorrow at 8 p.m. Bangkok time. This now represents robots that must go into confined spaces, collapsed buildings, for instance. The nice thing about this scale, even though it is still full size, it's full size in a smaller environment, is that now you can have the robots built using rapid prototyping techniques, 3D printing, laser cutting. And so this is the scale that we have been using as outreach into the high school teams to bring them into the real research challenges of the league. When, again, we'll talk more about this tomorrow. We're also adding new terrains with a focus on legged mobility. And we'll talk more about that in a moment. Now we have some reality to deal with this year in terms of the rules and regulations. We know that while all of you would love to be in Thailand, some of you are not going to be able to. So we are having a combination of remote, online, and in-person competition. And the nice thing about using the standard test methods is that the individual tests that are common within the preliminary rounds are directly comparable between the remote facilities and the in-person RoboCup Championship. The remote teams will therefore be eligible for some of the best-in-class awards where they're directly comparable, but of course only the teams that travel to Thailand and compete in person are able to participate in the finals. So how is the qualification process performed? First, the teams have to declare for the in-person competition their intent to participate. This is via the team participation form, which went out on the mailing list a little while ago and is due very soon at the end of this month. All this does is declare your intent to participate. It doesn't commit you to anything, and all we need here are some basic details about the name of your team, your institution, and who's in your team. At the end of February, we will then require a team description paper to describe your entry. And this year, we will also have a requirement that there is a video. We'll talk about what that video is or is a little bit later. And there will be a Best TDP award. Regions where there are many teams, generally more than 5 teams, will be asked to also hold a local regional open from which the best teams, up to 5, will be selected. Now for the online competition, we can loosen things up a bit because we don't have as much of a space constraint. All teams are welcome. We encourage you to submit a team participation form so we know who you are and can keep you in the loop, but it is not required. The teams must submit a team description paper as before, but now they can do this when they submit their preliminary video package, which we'll discuss in a minute. So This year, we are requiring qualifying videos in order to prove, if you're going to come to the competition, that you're capable of actually having a robot go through these test methods. This should be easy for anyone who's actually serious about this and has participated in the past. All we require is a video of a robot of yours, not necessarily the one that you're going to bring because we know you're going to improve it, but a robot of yours performing at least 2 of these tests. And this robot should be no more than 1 in-person competition year old. So it could be from 2019 because that was the last time we ran in person. And the tests are the dexterity, non-contact linear rails, align. We have a new test that we'll talk about, mobility 3, the K-rail crossover slope for mobility robots, or mapping in a hallway with 1 or 2 rooms containing at least 5 fiducials. And as I said, the teams do not need to use the same robot. In fact, you could use a small robot at a smaller scale performing these tests, which means you could actually build this at the 30 centimeter scale to demonstrate your ability, but then field a robot at 120 centimeter scale. We do have an out for new teams who do not have any working robot at all and are building up to their working robot. They may skip this requirement and be judged on the excellence of their TDP, but they have to prove that the team members and organization have not competed in the past. So here are the test methods that we expect. Align has been made simpler, so it should be easier to build linear tasks. We'll talk about in a minute. Crossover slope is a new one that replaces the step fields. And of course, mapping. These are all ones that should be familiar to those who've competed in the past. The video that we expect is uncut video in this quad screen format, so we can see what the operator is seeing, what the operator is doing, as well as an overview and detail of what the robot is doing. The nice thing about these standard test methods is just based on this video, we can score the video and score the run. Again, we realize that at qualification, at TDP time, the performance is not going to be at the level that will be the final fielded robot. So this is just as a sanity check to verify that you're capable of putting these robots together. The team description paper follows a specific format, which will be in the rulebook. But just some basic information, although there is also an award for teams that go beyond this and provide something that is also very useful to other teams. So what are the overall test methods in the competition? And these are test methods for in-person competition. A subset of this will be what we use for the online competition, because of course we're not expecting everyone to build all of these in their own facility. So this year we have some changes. We have now man 0, maneuvering 0. These are maneuvering suites, which is sustained speed, just the basic sanity check of can you get downrange on a line. We have center, which has changed, which has been updated to be simpler and more reasonable to robots of different aspect ratios. We have align, which has been made simpler. We have traverse, which is moving on a slope with some precision. We have crossover, which is this basic terrain, crossover ramps, or pinwheel ramps in this case, and negotiate, which actually came from our colleagues' work in Japan, with Professor Kimura was leading that, where the robots have to go through an environment where there are non-vertical obstacles that need to be avoided or pushed out of the way in a specific manner. Mobility tests, we have some new ones again. We have elevated curb, which is a diagonal rail that elevates, and this replaces the hurdle. So the top doesn't roll anymore, but it is at 45 degrees from the direction of travel in a narrow space. Sand and gravel makes a return on this kind of crossover slope. We have the K-rails, which is an easier to build terrain that replaces the step fields, but is still very challenging. We have the crossing ramps on crossover slope, which is new. The configuration of the ramps is to be determined. And of course, we have the stair debris, which represents some of the challenges of response situations, such as what happened in Fukushima, where you had a stair that the robot needed to go up, but debris had fallen on the staircase. We also have the dexterity tests. These are the tests that were run last year in a remote setting, but these are going to be the way that they're run in person now. We have the linear tasks, which are along a line, but at different angles. Omni tasks, which are around an object. Strength, which is lifting a weight in a controlled manner and pulling it out of the terrain, as well as shoring, which is using the robot to build a structure. And these are performed at different heights, different elevations, and so on. Here is a bit of video of some of these tests. In this case, this is Team Hector Darmstadt using a commercial robot. This is the Telemax, and they're performing the Omni extract. They're pulling objects out of this. This represents moving around an object in the space. In this case, demonstrating very nice coordinated control or inverse kinematics in order to pull those objects straight out so that they don't get jammed. We also have here we go. We also have, in this case, an example for shoring. In this case, where this is Team Shinobi and they are building this this structure. And fast forward it just a little bit. Okay. And this requires some level of precision and is made more difficult by the fact that there is a post in the middle of the apparatus that the robot shouldn't knock over. We have some new tests as well here. This is the crate and pallet terrains for autonomous mobility and legged mobility. These terrains start off simple like this, but then they go up and they need to be overcome autonomously. This requires robots that can sense the terrain and either step over them if they're legged robots or reconfigure themselves if they're tracked vehicles with flippers and other variable geometries. We also have the crate-based terrains, which have very large negative obstacles. These crates, some are upside down, some are right way up. And so any vehicle traveling over them needs to be able to avoid the crates that are the right way up and present very significant negative obstacles. So here's a better picture of it, along with a robot that many of you may know, the Boston Dynamics Spot, picking its way through it and avoiding the holes. And here's an example of Team Shinobi autonomously driving through the flat version. But of course, later on, they also then do autonomously the raised version as well. For search and inspect, we have an environment in person. It is a standardized labyrinth. For the folks doing it in their own facilities, we provide guidelines for instrumenting your own natural environments with these standard test methods. These are standard rails for inspect objects, each with a different identifier and an eye chart. There is an open one, which is very easy to see. We have a directed inspection, which means you have to be lined up with the bucket in order to see it. And then we have one with a hole in it, where in order to see the target properly, and that is to see the entire colored ring, you need to actually be in a specific location in front of the bucket. This forces you into specific locations in the environment and tests your ability to deploy your sensors specifically where they need to go. For mapping, we also have these half-round fiducials. We often use concrete forms to build these, but you can also build these out of any number of other materials. And you'll notice that they hang on two sides of walls. The idea is that if you map one side, you get half of the fiducial, and then when you go around and eventually get to the other side, you see the other half. And if the two halves match up, that means your map is has maintained its shape all the way around. You haven't lost your localization. Whereas if they get displaced, it means that your localization and map has broken a little bit. So here's an example of a natural environment for mapping. We're going to go through this fairly quickly. There's also uneven terrain that the robot has to drive over in order while it's doing its mapping. And we also have, in this case, this is inspection. You can see where the rail has been placed as an object of interest in the environment, and the robot needs to drive up to it and use this manipulator to get close to it and inspect the different targets. As you can see, you can't see into the one on the far right until you get close, whereas the ones on the left and in the middle are significantly easier and test your different abilities to direct perception. Okay, so competition logistics, how do we organize this? So in the in-person competition, in preliminary rounds, each day is divided into 30-minute synchronous time slots. This is how the competition stays in time. Everyone shifts on the same clock. Every day, teams take turns selecting which time slot and test to run. So for every time slot, every test is available, with at most a certain number depending on how many people we have to judge and referee. At the end of the preliminaries, for every test, the scores are normalized to 100 points. This is how we compare the easy and the hard tests on the same yardstick. A very hard test, even if only one team is able to do it, they have some performance, they get 100 points. Whereas for an easier test, to get the 100 points, you have to be the best. We have to be the best in both cases. And the best total in each suite is awarded the Best in Class award. In the preliminary rounds, at a prescribed point in the run, the readiness test is performed. This tests the performance of the sensors and manipulator that the robot would need downrange once it had gotten over the terrain that the test methods are designed to test. So this proves to the competition that, for instance, once you're partway over the terrain, you haven't broken your sensors and manipulator is still working. For the final rounds, the test methods are grouped into operationally relevant sequences that are performed one after the other. The readiness test is performed at various locations in the sequence, representing victims that you might find or objects of interest that you might see as you're going through an environment. And there are various manipulation tasks that are also performed. In this example here, it's carrying a crate through the hurdle, which is actually an old test that's not in this year. But we can also have robots placing objects or turning valves or the like. For the remote online competition, we do this using uncut quad screen video uploaded to a public timestamp video sharing site such as YouTube, with the team scoring their own run. Now, the teams only upload their best run for each test and setting that they wish to declare performance in. By doing this publicly, everyone else can then attest to the scores. You can check each other's scores randomly and make sure that there haven't been any mistakes. The scores are normalized as before, and the top teams, assuming they've also submitted a team description paper, then progress to the Best in Class remote finals. Now, we can't directly compare these, of course, because these preliminaries remotely are done with the teams selecting their best run. So the Best in Class remote finals are performed live on a video conference with judges and the public just prior to RoboCup week. And where relevant, for instance, in the mapping or in the search and inspect task, the judges can request last-minute changes, such as moving the fiducials around, just to make sure that the maps and the performance is reflecting what is happening currently and not some kind of not based on some pre-recorded policy. And the resulting performance in the common tests, as mentioned, are directly comparable to the in-person best-in-class runs. But of course, the ones who are doing this remotely aren't going to be eligible for the championship awards. So that's it from me for the competition logistics and for the introduction to the league. I'll now like to hand it over to Professor Tetsuya Kimura from Nagaoka University of Technology in Japan, who will be giving the technical presentation on the history and motivations of RoboCupRescue. Thanks for your attention, and we hope to see you in Thailand.
Thank you, Professor Raymond. So thanks for giving a wonderful talk about the introduction, especially the rules and regulations for the especially for this hybrid case. We all are get like more confused with the rules. So it would be great that we got it. So thanks once again. And I would like to invite Professor Kimura to give a wonderful speech. Before that, I would like to give here a small description about Professor Kimura for everyone who is listening. So Professor Kimura is one of the executive committee member of RoboCup Federation. He received his Doctor of Engineering from Tokyo Institute of Technology in 1985, especially in nonlinear controls of pneumatic actuators. He was a research scholar of Kobe University and Osaka University. In 2001, he moved to Nagoya University of Technology and is now he presently is an associate professor of Department of System Safety Engineering. His research interests mostly of robot control standard and robot innovation and also robot safety. He served several rescue robot promotion activities, including RoboCup, and he received he received a high-level reputed awards by the Prime Minister of Disaster Prevention Distinguished Service in 2020 recently. So congratulations, Professor, and welcoming you to your talk. Please. Professor, we are not audible.
Okay. Can you see
Okay.
my slide?
Yeah, we can see and we can hear.
Okay.
Great, perfect.
I'm sorry. My previous meeting is delayed, so I just arrived at the station. So now I can have a stable Wi-Fi. So my talk is to introduce you some technical background of why STM is so important for robot development and utilization. And the standard test method is very abstract and easy to fabricate. And sometimes uh, audience of RoboCup or a researcher who are not so familiar with STM ask me, oh, it's very cheap, and why you are developing a very important rescue robot? Very important. Why you use such cheap device or facility to evaluate that? Because real disaster situation is very complex. See the photo of tsunami disaster. I myself take this photo. It's a horrible situation. And rescue robot, response robot should work in such a horrible, very complex, unstructured environment. But for the researchers, especially for university researchers, cannot reproduce such complex and big disaster rubble. So instead of such real rubble, usually mock-up are used to evaluate robot performance. Yes, it's a very maybe it's okay and reliable, and comparing to the real disaster situation, easy to use, but still not good for university laboratory. And the standard test method. You see the picture of the ASTM E2828-11. It's symmetric step field. You can buy this standard through Intel homepage. Everybody can get this test method standard. And standard test method is repeatable, reproducible, inexpensive, quantitative evaluation for basic performances. And as Raymond explained, STMs are developed in a comprehensive, logical, and reliable way with stakeholders. Stakeholder means manufacturers, users and responders, academia, by everybody, and main stakeholder is NIST. And why STM? from the viewpoint of user or responder. Today my talk I introduced some useful keyword, and one of these is interagency board. Number is 03OE07 robot. That is, this interagency board is a group of responders and responders who gives some advice what the responder should do. And in this standard, they said many responder organizations evaluate robots thoroughly on the promised capability of manufacturers. However, comprehensive evaluation of such marketing data is extremely difficult due to differences in manufacturers' terminology and test methods. Standard test methods such as STM series can be used to provide objective and reliable data on robot capabilities. Responders can trust the data captured at any participating accredited test facility, no matter when or where the test was conducted. No matter when or where, if they are accredited. So if your facility in Thailand is accredited, that data can be used over the world. Okay, this standard also tells homegrown performance specifications often result in requirements that compete or conflict with each other. This has consistently lead either to inadequate performances, excessive cost, or both. Purchasers should make purchasing decisions by specifying a variable combination of robot capability as defined in standard test methods that reflect their beyond mission tasks. And purchasing organizers should require that candidate robot manufacturers have their robot evaluated according to the applicable ASTM standard test method, and require that each manufacturer provide a copy of the completed test method chart indicating how the robot score in the required suite of tests. This is, you can see this information from the homepage of interagency board. This is a very good summary why STM is important. And to develop that, in the US, Adams Group, and in Japan, my group, both are awarded in 2020. It's a government view of such STM development. Also, important letter we got is from an EOD staff. Raymond, are you at that site when we have this letter? Do you remember that?
I remember that, yes.
Yes. So at the end of the ASTM meeting, a guy visited our meeting room and handed this letter to Adam. First, I think, oh, our meeting time is over, so we should hurry out to get clean this room. No, this letter is from an EOD staff. This says, ladies and gentlemen, thank you. When you design and build has saved my life on hazardous occasions and the lives of countless sailors and soldiers. I think I can speak for all of us when I say you are doing a great service for EOD teams around the world. So again, thank you very much. I hope you have enjoyed your stay here in Indianapolis. Taylor R, Navy EOD Mobile Unit 2. I was very impressed to read this letter. So we are doing our best to support EOD staff. But I'm an academia, so I'm not so sure. I'm not fully sure my standard is really effective for real, very tough, severe condition or not. But this letter tells me, okay, our STM is work for such a very severe condition. Okay, I will introduce you to Two keywords. Why STM is good for response robot. One is from engineering. Keyword is systems engineering. This is originated by NASA, and NASA said systems engineering is defined as a methodological, multidisciplinary approach for the design, realization, technical management, operations, and retirement of a system. That is, the systems engineering covers the life of a system development. And this systems engineering is for complex products, like a rocket. That rocket is a feature of a small number production and high reliability. This is very suitable for response robot because response robot market is not so huge like industrial robot, but it should be high reliable. So this systems engineering is suitable to response robot development. And the two important test methods, verification and validation, is a key of systems engineering. And the verification is individual test. Yes, it's a STM itself, and the validation is a comprehensive test in a scenario. Both should be used in systems engineering, and STM can be correspond to verification. Another topic from economics, co-creation is now important keyword in economics to develop a nice product. Recently, customers' need is diverse or complex, so many companies try to develop nice product to get money. But usually, customers are not fully satisfied that product. So economic people think, okay, to develop nice product to satisfy such a diverse customers' needs, stakeholders cooperation from the beginning of the product development. That is called co-creation. That paper is published in 2004, and in the for co-creation, all ideas are very important. The first one is dialogue. It's very important and very difficult because the stakeholders' background is different. So dialogue is important but difficult. And transparency of information is important. Access to information is important. Risk-benefit balance is also important. Standard test method is developed as a standard. And to develop standard, first party, second party, third party should cooperate with each other. This is also standard to develop standard. So standard enhance dialogue among stakeholders during its development. So I think that from the viewpoint of co-creation, STM is useful to develop nice products. So STM has many advantages to accelerate robot innovation. Then METI in Japan decide, okay, they start a World Robot Summit. This is a robot category, robot competition for innovation of robot development and social implementation. And there is 3 challenges. The first one is the plant challenge. We have 5 tasks. It's the plant inspection. And tunnel challenge, it's a simulation. And 4 tasks for tunnel accident, car accident, and also a tunnel inspection. And the last challenge is STM challenge. It's a Japanese version of STM for plant and infrastructure inspection. This is Japanese government order to develop such STM. They need this. And these STMs are complementary to the current NIST test method. That is, current NIST standard test method is for urban search and originated urban search and rescue and EOD. So this Japanese standard test method can be complementary to cover all the application of response robot. So I think this RoboCup 2022, many Thai people will join. So if you can develop your own STM to accelerate your own application, yes, it's good. And we can change the idea and cover and extend our application of the response robot. That's all. Thank you very much.
Thank you for Professor Kimura.
Thank you so much, Professor Kimura, for your wonderful speech. And it's more exciting to know about what's to be considered and what are the factors to be known. And I would like to say once again thanks to Professor Kimura and Professor Raymond. And now I would like to invite our local organizing chair, Professor Hirapat, who is working as a professor in Bangkok. Moreover, he's like served in RoboCup, but he took part in RoboCups more than 10 years, and he have enough experience with Rescue League, especially. And Professor Pirapat, you please say some words and give words of thanks to our guests and conclude the session. Then we will go for the Q&A.
Thank you for Professor Lehman and Professor Kimura. Really grateful, very great for your experience, and thank you for sharing us about the whole the big picture of the Rescue League. And I think for that is a good opportunity for our audience to join our league and test about your robot. And I think I can meet you all in Bangkok. And also, please enjoy for the Rescue Robot League in Thailand. Thank you very much for everybody, everyone. And I think maybe our audience have many questions to ask about the regulation, and I think for this valuable time, I will give the valuable time for our audience to ask a question. Thank you.
Thank you, Professor Pirapat. So it's a time for audience. If you have any questions or clarifications, please raise your questions.
I will point out that we have made some changes from past years, and these will be reflected in the rulebook that will be coming out soon. So please go to our website, join the forum, join the mailing list to be kept up to date with when those things come out. So, I've put the link in the chat. Okay, so we've got a couple of questions. So the first one, will the slideshows be made available somewhere soon? Yes, they will be. And I believe the video for this is also going to be published. Is this correct? It's recorded?
Yes.
Is that
this? We will
okay.
for our video, our record.
Perfect. Okay, so that will be available at least. For the first-time participants, so in general, we want everyone to be to have a video of a robot. It doesn't have to be your final robot. It doesn't have to be. It could be a robot that you already have that can perform some of these tests. We just want to be in a situation where we know that this team is capable of building a working robot that can and has built some of these test methods. If you don't have the ability to do that, and you can prove you're a new team, so you're not from an institution that has competed before, and you don't have team members that have competed before, then we have the ability to accept just based on the TDP. It has to be a very good TDP. So that is possible. But where possible, we do encourage you to build the apparatuses. If you remember, so the two apparatuses that you can do is the they're designed to be the ones that are easy to build. So if you're aiming for mobility or manipulation or whatever, these should be the basic apparatuses that you should be building in your lab as part of your development. Is there a weight limit for the robots? Yes, there is. I honestly can't remember exactly what. So there's been a decreasing. We're trying to get the robots lighter and lighter. So every year for the past few years, we've reduced the weight. I don't remember what we're up to now because I'm not quite sure how they're counting last year. So we'll have to get back to you on that. But yes, there is a weight limit for the robots. It is in the rules. And I can very quickly look that up. Or at least I can look at what they were in 2019. Here we go. Okay, so in 2019, 100 kilograms was allowed. From 2020, the plan was 80 kilograms. Of course, 2020 didn't happen. So I'm not sure. We need to double check if it's 80 kilograms or if it's less than that now. It will be in the rule book. And if there are questions, you can also send us email and we can get back to you on that. Will there be a European Rescue RoboCup too? I actually so usually there is the German Open. I believe for this cycle that actually happened earlier. I think that actually happened last year because it was coinciding with the opening of one of their facilities. So yeah, I honestly don't know what's going on there. You're going to have to check in with the German the German RoboCup organization for that one. Yeah, so I'm not 100% sure what they're doing for this year. I would check because of course COVID is making life interesting as well. What is the weight limit for small robots? So we haven't really had a weight limit for the small robots just because generally the limitations of building something that will fit in the arena and that people can pick up has been the limiting factor there. I mean, don't build the robot out of lead. But for the small robots, that is for the RMRC, right now, I don't believe we have a practical weight limit just because robots have been hitting the size limit first. We may have to revisit that if we start getting teams putting very heavy robots in, but I really don't think that's likely just because you get to a certain point and the motors and the bearings and the batteries you have at that scale just don't work anymore. Any other questions? Let me see if I can find links to the folks who are running the German Open. Ah, perfect. Okay, May 2022. Perfect. Thank you. Okay. I should probably remember that link too. Okay, any other questions?
Can I ask something about the manipulator?
Sure, please do.
About to test the manipulator performance, we have to build the structure, right?
Yes,
we
but
have to carry a wood.
I'm sorry?
We have to carry a wood, a piece of wood to make a structure. Is that right?
So there are several standard test methods for manipulated dexterity. One of them is called the shoring test, and that is the one where you're building this vertical structure out of pieces of wood. But that's only one of the tests. There are several other tests as well in the manipulated dexterity suite of tests.
And how about a wood weight?
The weight of the wood. Okay. That will be in the rule book. I don't remember exactly what the weight is. We've kind of swung back and forth a little bit. In the 2019 rule book, they were 60 centimeters in length and approximately 1.8 kilograms in weight. So that's the kind of magnitude we're talking about there. Which is a little different to what you saw in the other video. So I imagine it's going to be the same when the new rulebook comes out. But refer to the new rulebook once that comes out, and that should be out very soon.
Thank you.
Any more questions?
Then I think this is all the question from the audience.
If there is no more questions, I hope we can close the session.
Okay, well, thank you so very much to everyone, and especially to the local organizers. We really hope that we can all gather in Thailand this year.
So,
and before we close the section, can we take a group of a photo for this section?
Yeah. Please, everyone on your camera for a while. Have a group picture.
Mr. Rashad.
อย่ามองแคบอาจารย์ Okay, 1, 2, 3. Look at the camera and smile. Okay, handsome. Okay, ค่ะ finish.
Thank you.
Thank you.
Thank you so much.
Thank you so much, Professor Raymond and Professor Kimura. Thank you so much.
Thank you very much.
Hope to see you soon.
To see you soon.
Hopefully, yes.
Thank you. Bye-bye.
Bye.
Good night. Good night for Professor Kimura and good day for Professor Raymond. Yeah.